So this is a video on oxidation and reduction. In this video we're going to find out what oxidation and reduction actually mean in terms of electrons, and to define the terms oxidizing agent and reducing agent. So the terms oxidation and reduction refer to the idea of the movement of electrons when a reaction happens. And to remember which way the electrons move for oxidation and reduction, you can remember a term, and that is the term oil rig. And what this means is oxidation is loss of electrons and reduction is gain. So if an element has lost electrons during a reaction, that means it has been oxidized. If an element has gained electrons during a reaction, it has been reduced. So oxidation is loss and reduction is gain of electrons. Now to work that out, you can use oxidation states, which is covered in a different video. So the next aim is to understand what is meant by oxidizing agent and reducing agent, and to understand this we're going to look at a reaction, and that reaction is going to be between sodium bromide and chlorine, which when reacted together makes sodium chloride plus bromine, and we've just got to balance this as well. But to be honest, when sodium bromide and sodium chloride are dissolved in water, which it would be in this reaction, the sodium ions and the bromide ions, and the sodium ions here and the chloride ions, when it's reacted, are separate in the solution because they dissociate. They float about as Na plus and Br minus and Na plus and Cl minus. So actually the Na plus ion is just a spectator ion. It doesn't really do anything in the reaction. So to discuss what happens to the electrons during this reaction, I'm going to write this as an ionic equation instead. And an ionic equation just gives you the reacting ions, or the reacting elements. So it's going to include the Br minus ions from the sodium bromide, the chlorine, the Cl minus ions from sodium chloride, and the bromine. So that will give us 2 Br minus plus Cl2 goes to make 2 Cl minus plus Br2. There should be 2 there. So I'm just going to get rid of the stuff at the top we don't need. So if we think about what happens to the electrons during this, we can see that this bromine here has gone from a Br minus to just a Br2, the element. So here, this has lost electrons because it's gone from a negatively charged thing to something that hasn't got charge at all. So this has lost electrons. The Cl2, however, has gained electrons because it's gone from something that's not charged at all to something that is negatively charged. So this has gained electrons. This means that the bromide ions have been oxidized, oil, have lost electrons, and the chlorine has gained electrons and therefore has been reduced, if you follow oil rig. However, the terms oxidizing agent and reducing agent refer to the idea that they have oxidized the other thing or reduced the other thing. So bromide ions, in losing electrons, has given those electrons to the chlorine, so it's facilitated the reduction of the chlorine. And so if it's been oxidized itself, it is also the reducing agent. So the bromide ions are the reducing agent because it's been oxidized itself. Similarly, the chlorine has gained electrons from the bromide ions. So in being reduced, it's facilitated the oxidation of the bromide ions, and so the chlorine has been is the oxidizing agent. Which is reduced itself. So if you put the word agent after the term, the opposite has happened to itself. And so that's a way of remembering whether it's been oxidizing agent or reducing agent. You can find out what's happening to itself, and then you just reverse the term. So here's a question from a past paper that requires your understanding from the previous few slides. The first bit doesn't, and will require you to watch a different video if you're not sure how to do it. So the first bit's write a half equation for the conversion of Mn2 plus in acid solution into Mn2 plus ions and water. And to do that, first you will write out your reagents that are reacting and being made, your products, and then you balance anything that's not hydrogen or oxygen, which is already balanced, that's the Mn. You then balance the oxygens by adding water to the other side. So we're going to add 2 lots of water to balance those oxygens. Then we're going to balance hydrogens by adding H+, and you can see we've got 4 hydrogens here, so we'll add 4 H+ onto this side. And then you've got to balance the charges with electrons. Now, you'll see here that there's 4 hydrogen pluses here, so that's a 4+ charge overall, and you've got a 2+ charge on this side. So that means you've got to bring this side down to 2+ by adding 2 electrons. Okay, now if you don't know how to do that or didn't follow that, then please watch the video on redox reactions, which goes through how to write those out. So the next step asks you to state what is meant by the term oxidizing agent in terms of electrons. So remember, I said that an oxidizing agent is reduced itself. So you could say an oxidizing agent, because it gets reduced itself, will gain electrons. And then it says, identify the oxidizing agent in the overall reaction, where you can see in the reaction that this side is having electrons added to it. So the MnO2 is the oxidizing agent because it is gaining electrons. You can see that from the equation. So the oxidizing agent is MnO2. And the oxidizing agent is the whole compound, not just the element that's getting reduced. It's the whole compound. Here's another past paper question that requires some knowledge from the extraction of metals topic, which you may not have covered yet. So I'm just going to do the first question for you. So it says, write an equation for the extraction of titanium from titanium 4 chloride using magnesium. So that is done by, so it's titanium chloride plus magnesium goes to make titanium by itself, and magnesium chloride, which is MgCl2. So you need to balance this by having 2 MgCl2s and 2 magnesiums. And it says state the role of magnesium in this extraction. So you're basically asking you whether it's an oxidizing agent or a reducing agent. And you can see that titanium here has 4 chlorines attached to it. Now each of those chlorines are going to be negatively charged. So the titanium is going to be positively charged here. And the titanium here is just an element, so it's going to be neutral. So if it's going from a positively charged thing to a neutral thing, it must be gaining electrons. So that is being reduced, which means the magnesium is facilitating that reduction, so it must be a reducing agent. You can check that by checking the magnesium is being oxidized itself. So you can see it's going from something that's neutral to something that has negatively charged things attached to it, so it must be positively charged itself. So it's going from a neutral thing to a positively charged thing, which means it's losing electrons, which means that is being oxidized. So this role does make sense. Please let me know if you need any more help with any of this by email.